Hello, we continue to study the motion of a body with acceleration, and today we will consider a special case of it, free fall. What is free fall? This phenomenon was studied quite a long time ago, and one of the first scientists who was able to answer this question was Galileo Galilei. He conducted his famous experience of throwing various bodies from the Leaning Tower of Pisa and established that bodies, regardless of their shape, size, mass, should fall with the same acceleration to the ground in the absence of air resistance. Let's check this experiment in practice. If we have two identical pieces of paper and see how they will fall, and let them fall in different forms. That is, one piece of paper we will leave untouched, and the second piece of paper we will turn into a lump like this. As we understand, these two pieces of paper are exactly the same in mass, but now they have different shapes. The Earth also attracts them to itself equally, and now the question is how they will fall from the same height. We see that a lump of paper fell much faster than a sheet of paper, though once again we repeat that their mass and attraction are the same. This shows that air resistance really has a very great influence on the fall of different bodies, and if this factor is removed, then all bodies will fall in exactly the same way. Galileo told about it in his works, and later this experiment was confirmed by Isaac Newton, who in a pipe from which the air was pumped out was able to reproduce this experiment and prove that really, regardless of the shape, size, mass of objects, all bodies fall to the ground with the same acceleration. And this motion was called free fall. Thus, when we talk about free fall, we understand that only one single force will act on the body. It is the gravitational force of the Earth without any additional forces, such as, for example, air resistance. Therefore, in the tasks, when we talk about free fall, we automatically neglect air resistance. Although, of course, this phenomenon will always be present in our life, and in real life we cannot neglect it. But in the tasks, we make such a simplification so that we could solve the problems more simply. What are the parameters that describe such motion? First of all, of course, it is the very value of the acceleration with which all bodies fall. In this case, the acceleration of free fall is denoted by the small letter g from the word gravity. And further, we will solve problems using this parameter, substituting it instead of acceleration in all the formulas known to you and me. What is the acceleration of free fall? According to many calculations, it was shown that this value in general varies depending on the area where you and I are. But on average, if we take all the calculations that have been made on Earth, then we come to this approximate value of this value. (9.81 meters per second squared). This is the average value of the acceleration of free fall, and for solving problems we will take it. Depending on how we will direct the coordinate axis, which will describe this motion, of course the projection of this acceleration on this axis will have a plus or minus sign, depending on the situation. So let's use the figure to show this. Let's say we have the surface of the Earth, and there's a body that falls to the Earth with no initial velocity. So the initial velocity is 0. In this case, it turns out that the body at any moment of time will have a given acceleration. That is, it will constantly gain speed, and in the process of this movement, before hitting the Earth, will have some final velocity, which we can determine by a known law, the law of velocity. In this case, we can enter the coordinate axis directed both vertically upward and vertically downward. In general, there is no big difference here, but suppose for convenience we can y-axis, in which the body moves, to direct downward so that all projections of these values were positive. Then we can write the equation of velocity in this form. And it will be possible to estimate the velocity at any moment of time, given that we now know what the acceleration of the given of the body. Similarly, throwing a body vertically upwards, We can calculate the final velocity of the body in a similar way, knowing the value of the initial velocity and the value of the acceleration. The only point is that now the signs of these quantities will be slightly different. Suppose we threw a body with some initial velocity vertically upwards. And now we can point the coordinate axis vertically upwards. The acceleration g is pointing vertically downwards. And let's say we need to find the velocity at some point in time. Then we see that this velocity will be determined by the same equation. That is, the initial velocity also has a positive sign of projection, but the acceleration now has a negative sign. So this minus we must add to this equation. And thus we get two equations for calculating velocity, which we will use in solving our problems. This is the first mathematical treatment of this motion using the law of velocity. Of course, free fall is not just the motion of a body falling downward. That is, we must get used to this concept and realize that free fall will be called motion in any direction, regardless of whether the body falls or rises up. The most important thing is that in the process of this movement, nothing but the gravity of the earth acts on the body. This factor we will have to take into account in solving problems. The direction of the throw can be absolutely different. That is, we will consider different situations. This is the falling down, this is the upward movement in the vertical direction, this is the body thrown horizontally and the body thrown at an angle to the horizon. In all of these situations, this motion is called free fall. Now let's see how the coordinate of a body that falls freely is calculated. To do this, we will use the already familiar coordinate equations that we derived in the equation of equivariant motion. And now our task is simply to substitute for the acceleration a, the acceleration g that we know, and then the value of the coordinate of the body. In this case, it's either the x coordinate or the y coordinate, it doesn't matter. We get an equation for the coordinate like this. Making similar calculations, we can also see that the rest of the equations of equal variable motion will also fit here absolutely identically, i.e. we talked about the coordinate and its dependence on time, but we also know that we have equations in which there is no time, so let us now write down the equation of displacement, in which we also have the acceleration with which this of the body. In this case, s is the vertical displacement of the body, i.e. it is necessary to show that we are considering this motion in the vertical direction, up or down, it does not matter. The main thing is that we will solve problems in the vertical direction. This is the component that this equation will describe. And of course, in principle, we can use the equation without acceleration here too. For convenience, we will also use it if we need to relate the initial and final velocities and time of motion of this body. Therefore, in general, all these equations that we talked about today, they will be suitable for solving these problems, and when we consider free fall, we will analyze which of these formulas is more convenient to use to solve the problem. That's all. See you all soon. See you at the practical class.